Good evening, everyone, and welcome to our final Capstone presentation. We are Team NavVizor. Our team comprises of Ashwitha, Jathan, Bhavana, Andra, and myself, Swarna. Today, we will be presenting our topic along with the research problem. We will walk you through our research methods, findings, and how we arrived at our prototypes. We will elaborate on our evaluation methods and conclude with our results. Over to you, Bhavana.
Thanks, Swarna. So, let's explore our topic in detail. And imagine if you're driving through a bustling city and relying on your navigation app, and it tells you to turn left, but a confusing maze of streets is ahead. So, existing navigation apps often fall short of delivering clear and accurate guidance. Our project focuses on understanding those driver challenges and exploring ways to minimize those cognitive load and enhance their driving experience. Next. Our primary objectives are to provide clear and concise guidance and keep drivers focused on the road and their surroundings. We aim to enhance their drivers' attention by making it more engaging and enjoyable. We also strive to minimize their mental effort by simplifying navigation instructions and also streamlining the decision making process. Let's discuss our research methods which we use. Our project began with a thorough literature review, followed by benchmarking the existing apps. We then conducted focus group interviews and contextual inquiries to gain more valuable insights. We conducted a literature review with 20 research papers and tech articles. We discovered that AR reduces the cognitive load on drivers compared to heads-up display. On the other hand, we also found that the users accepted personal navigation devices with heads-up display better. Test subjects in the papers that we studied felt that the timing of the visual information was very critical. Another finding also shows that when AR was integrated with the real world, it was hard to differentiate between the real and the augmented environments. So here's how we approach the benchmarking different navigation technologies. So first we looked at the familiar navigation apps and then the current technologies which we have like HUDs and in-car augmented reality entertainment systems. Then we carefully examined the features of each and weighed their advantages as well as disadvantages. Lastly, we assessed how advanced each company was in developing these technologies for navigation purposes. So here is a summary of our findings from benchmarking traditional navigation apps like Google Maps, Apple Maps, and Waze, which you can see onto your left. So we discovered that common features such as voice direction and easy point of interest search and displaying speed limits are available in all these apps. However, Google Maps stands out with additional features like easy access to ratings and reviews. Also, Waze offers unique features like customizable voice directions and alerts for speed cameras. Now let's look at our AR navigation benchmarking. We benchmarked with Mercedes-Benz, Cadillac Escalade, Genesis, BMW, and Wayrig. We observed some common features across all the vehicles, such as displaying speed and distance, destination information, augmenting arrows, and voice interaction. However, Wayray notably tested and confirmed effectiveness of crosswalk and pedestrian alert, while parking availability was not implemented by any of these companies yet. So this comparison gave us a more clear view of strengths and gaps in AR navigation. So for our user study, we did a focus group interview with 3 groups and 12 participants overall. We covered questions around current driving experiences, their pain points, and using navigation app experiences. The participants mentioned about that they started losing focus during long distance drive and maintaining speed. They also mentioned that it is challenging to keep a track of exits on freeways and cutting through multiple lanes from extreme ends. Few of them spoke about distractions from co-passengers and also getting stressed about finding parking spots. Most participants preferred referring to maps on the infotainment over phones due to a larger screen size. They also highlighted some drawbacks with Google Maps, such as rerouting was confusing, not showing precise destination location, distracting audio interference when prompted at unnecessary events, or repeating the prompts. Few users also preferred audio and visual navigations combined. Many shared their frustrations when it came to changing destination or route while on the move. They also shared how voice assistants pick wrong locations while trying to change the location. Along with focus group interviews, we also did contextual inquiries. We took 2 rides with individuals who frequently drove in the US and also with an Uber driver. So we mainly noticed that the driver took sudden decisions when other vehicles tried to enter their lane. We also noticed frequently bending forward and looking left or right, checking for the incoming vehicles. Participants made at least 3 to 6 glances on the infotainment per minute. We also noticed them struggle at the point where they had to enter into a freeway, and within few minutes they had to take the very next exit. So after collecting all of this data, we synthesized our data by conducting affinity mapping. We transferred all our focus group interviews and contextual inquiry data to a Miro. We grouped them similar notes and into categories and identified emerging themes. So during the affinity mapping, we identified 9 themes, out of which we considered 4. To summarize our themes, I could talk about while changing destination, there is always a dependency on co-passengers, or they have to pull over to adjust their destination. Maintaining speed has always been challenging for users, as well as coordinating eye movements with speed limit boards, which makes user more frustrated. Merging and switching lanes often led to increase in cognitive load, leading to either missing their exit or adding up in unexpected situations like switching lanes. And lastly, as everybody knows, it's difficult to find a parking spot in downtown. Moving further, Ashwitha is going to talk about how we derived our user personas.
Thanks, Bhavana. Here are our user personas. Our first persona, Jordan, a 19-year-old college student, prioritizes simplicity over complexity, values essential tech features in his car. He is keen on leveraging technology to enhance driving safety and efficiency. Jordan seeks intuitive and user-friendly interfaces to navigate unforeseen situations effortlessly. He requires clear guidance on utilizing in-car features and prioritizing technology that minimizes distractions while driving. Next, we have Mari, who is 30, embraces new gadgets and apps. She drives a car with advanced tech features and enjoys exploring new routes while using navigation apps. Mari syncs her smartphone with the car's infotainment system and utilizes various connected car services. Her needs include seamless integration of her car with smart devices and access to real-time traffic and weather information. Let's now dive into our brainstorming and ideation phase. For the ideation, we used Crazy 8's method, where each of us had 8 minutes to sketch 8 different ideas, and we repeated the process multiple times. We generated around 65 ideas based on our themes generated through the affinity mapping. We then filtered those ideas using the star-based method. As a group, we evaluated each of them on a scale of 5. The evaluation criteria were based on the importance, feasibility, and novelty of the idea. Next, our shortlisted ideas were segregated as per user pain points. For example, users felt difficult in switching lanes, merging highways, and so on. Lastly, for all these ideas, our team generated storyboards, which helped in clarifying the vision and identifying the potential challenges. Once the final ideas were filtered, we moved on to creating our storyboards and conceptual UI. We built scenarios around the concepts and used the storyboarding method to visually articulate them. This method helped in visualizing the ideas that we had and defining the key elements we wanted to work on. Let's now look into our visual storyboarding in the following video.
Meet Sam, an enthusiastic traveler who cherishes efficiency and immersive experiences on the road. Like many of us, Sam starts his journey by relying on traditional maps, expecting it to guide him accurately to his destination. However, as he drives, Sam's frustration grows. Traditional maps proves to be inaccurate, forcing him to keep his eyes on the map frequently. Frustrated with the experience, Sam decides to search for an alternative. That's when he discovers NavVizor, an augmented reality navigation app that promises a more immersive and accurate driving experience. With NavVizor, Sam can select from various themes, each offering a distinct visual and auditory experience tailored to his preferences. Sam browses through theme options on the NavVizor app, scrolling through choices like Diamond Heist, Neon Arrows, Stranger Things, and Utopia. He settles on Diamond Heist. With NavVizor, Sam feels more connected to the road, as the navigation prompts him with timely instructions for turns, lane changes, caution signs, and more, all presented in a visually stunning and intuitive manner.
That was a storyboard. Let's now look into our process of building the prototypes. The first step was to convert our storyboards into feasible pen and paper low fidelity prototypes. The plan was to record the videos while driving in Dearborn and Detroit region and then augment our AR elements onto those videos. We considered 3 scenarios here. We considered freeways, local streets, and parking. The next step was to identify the best tool for building our high fidelity prototype videos. We did an in-depth research and implementations on tools like Adobe Aero, After Effects, Google's Geospatial Creator, Runway, and even tools like Canva and Clipchamp. We chose to go with After Effects for the following reasons. After Effects, as we all know, is a sophisticated tool that allows freedom for designers like us to go above and beyond. We utilized the 3D camera tracking feature as shown in the image to the right that helped us process the surroundings and place the 3D AR objects in the air and on the roads. We also used motion tracking while placing AR elements as the car in the video was moving at a speed of 70 miles an hour. And as shown in the image, it allows 3D object manipulation along X, Y, and Z axis. And needless to say, it has advanced option for adding VFX and helped us blend the objects into the surroundings and made it look more realistic. Once we had our short high fidelity clips ready, we tested them out with the driving simulator. We tested our high fidelity prototypes at every stage to make sure that the elements did blend well with the environment and had good visibility. Here's the design system for our themes Diamond Heist and Neon Arrows. Our design system is a library of components including AR elements, colors, icons, typography, and much more. Each component is meticulously crafted by the team to align with our brand identity and to enhance the usability. And here's the design system for the floral theme and the traditional arrows. You'll see how we use these elements in the prototype video in the next upcoming section. Let's now look into our evaluation methods. So our primary evaluation method was usability testing. We had participants physically test our prototypes at the driving simulator lab at the university. We wanted to create an experience close to a real driving scenario, so we used Oculus, a VR headset, to show our video prototype. The videos were posted on YouTube and viewed through the Oculus. With this, we aim to make the experience more engaging for participants. For evaluation, we used methods like semi-structured qualitative interviews, NASA TLX survey, and Likert survey. We recruited 12 participants, and for each of our participants, we prepared a test condition comprising of 4 trials each. We had 4 themes, that is Diamond Heist, Neon Arrows, Floral, and Traditional AR. We had 3 scenarios comprising of highway, local road, and parking. As shown in the table, the themes and scenarios were randomized for all our 12 participants for the trials. For example, in the case of our second participant to the right, S1T2 indicates scenario 1 and theme 2, S2T3 indicates scenario 2 and theme 3, and it goes on. Here's a sneak peek into one of our participants' trials. We ensured that the participants were relaxed and they were less anxious. Ideally, our fully functioning product would allow users to see the elements on their windshield, but due to the technical feasibilities, we decided to show the AR elements on the VR headset to have a better test environment for our participants. At the end of each trial, we gave them the NASA TLX sheet to record their observations.
At the light, turn right onto Monroe Street, then turn left. Turn left, then your destination will be on the left.
And at the end of the fourth trial, they were given a quick Likert survey to fill. For the usability testing, we recruited diverse participants with valid US driver's license. Quantitative study was carried out through NASA TLX and Likert scale ratings. NASA TLX was used to measure the mental and physical load through each trial. Likert scale was used to gauge the overall effectiveness and satisfaction of the participants. At the end of the test, participants were asked a few questions related to their demographics, usability and effectiveness, and what aspects of AR they found most and least distracting, and display preferences and any issues that they faced. I'll now pass it on to Swarna to discuss the findings.
Thank you, Ashwitha. Here are the results from our usability testing. Participants indicated certain advantages of our prototypes over traditional navigation apps, like allowing them to focus on the road without looking at the map constantly. They liked that they received lane guidance, warnings, and spatial awareness. They mentioned special examples like being able to be on the right lane, differentiate whether they have to take roads or bridges. At the same time, they indicated disadvantages like elements appearing at instances where they're not expected to be, and those can be distracting. And they also highlighted that users would take time to get used to such kind of navigation. With respect to the display of elements, most participants would like navigation elements to be augmented above the ground and to be supplemented with text. Lastly, elements with a larger real estate on the HUD and with quick animations were found distracting. Some of the usability issues we identified were there was inconsistency with the size and frequency and duration of display of the elements. Some elements augmented in the air were out of the line of sight, and a few partially blocked the view of the vehicle in front. Users would like the flexibility to turn the AR navigation on and off as per their convenience, as well as text and voice assistance. Some signs did not follow universal standards and were found confusing. Lastly, some themes lacked context and were considered not that significant in navigation. The result of our ANOVA test did not showcase a significant effect on our display variations on the frustration levels. However, the theme-based navigation does not degrade the workload and is comparable to traditional navigation systems. From the Likert scale ratings, we learned that majority of the participants found that the AR features enhanced their navigation experience. The themes made them feel more engaged with their surroundings. They also believed that AR features offered additional value compared to traditional navigation apps. Users found theme-based navigation particularly useful for lane merging or switching lanes. However, there was a low perception among participants regarding the effectiveness of theme-based navigation in maintaining alertness on highways. We will now look at our final prototype. Based on the findings from our testing, we provided the flexibility for users to select their preferred theme and customize them with elements, display position, text, and voice assistance. The user in this case has NavVizor installed on their infotainment system. Upon loading, the user selects the Diamond Heist theme and is able to give preferences on text assistance, caution signals, and voice assistance. The preview is shown to the user based on their selection. The user can turn the navigation on and off with one click. With the neon arrow theme, as per user preference, the arrows are shown in the sky instead of mid-air or road. As you can see here, users can also choose to enable text assistance from settings. I'd also like to highlight that the themes we chose to prototype are only conceptual and can be customized in real life scenarios. Moving on to our conclusion. Although our study didn't uncover a statistically significant impact on the AR-based navigation on factors like demand, effort, and frustration among participants, these navigation systems were perceived positively in enhancing the overall driving experience, and they managed to maintain driver engagement with their surroundings. The results suggest that there's considerable potential for AR navigation systems to enhance driver performance, but further investigation is needed. While our initial findings didn't reveal substantial changes in key metrics, the perceived enhancement in driving experience indicates that there might be underlying benefits that require deeper exploration. Moving forward, our research aims to delve deeper into the concept of cognitive tunneling in conjunction with theme-based AR navigation. By focusing on how these systems affect drivers' attention and awareness, we hope to gain a more comprehensive understanding of their impact on driving behavior and performance. In the course of our Capstone project, some of the limitations we encountered were we experienced a creative block while ideating due to some feasibility constraints. Learning a new software like After Effects to build our prototypes in limited time was challenging. We did not have sufficient time to create VR-compatible videos. Since we tested in person at the lab, it was challenging to coordinate with participants' availability. We had limited time for multiple iteration cycles and feedback. Lastly, we could not test in live scenarios on the road. We learned a great deal with our Capstone project. We learned how to conduct a formal lab study. We learned that storyboarding is a great method to visualize ideas in a tangible way. We learned how to manage time and resources during user testing and recruiting, and how to moderate focus group interviews. Most importantly, design is a continuously iterative process, and there's always room for improvement. Here's some of the behind the scenes from our project. Although our learning curve is high, we had a wonderful time doing our Capstone project. We'd just like to extend our gratitude to Professor Kim for his constant support and guidance throughout the project, especially for supporting us with resources like the VR device, high-performance computers, and access to the lab. So thank you, Professor. Thank you all for your time and patience. We're open to any questions.